This example considers a challenge typically faced when a series of promising compounds have been found, but the chemistry needs to be broadened to further improve one or more properties. Focusing on a single property for optimization often increases the risk of introducing liabilities for other properties, and so in this exercise we're going to take a look at how StarDrop can help to explore new chemistry ideas while minimizing this risk. During this example we will consider 3 compounds from a lead series, which we would like to try to evolve into a candidate. The compounds have good profiles of ADME properties, but insufficient inhibition of the target, the serotonin transporter. In this example, we will use StarDrop's Nova module to generate new ideas for compounds to improve the potency while maintaining the balance of other properties. First, open the file novaleadcompounds.add by using the File Open menu. You will see a spreadsheet containing the 3 lead compounds for which a range of properties have been predicted. The compounds have been scored using probabilistic scoring against a profile of properties suitable for an orally dosed compound intended for a CNS target. The third column in the dataset is called Serotonin Transporter log Ki micromolar, and the values in this column have been generated by a custom model built using Kemble data with the StarDrop automodeler. These values are used when calculating the overall scores, and so in order to calculate this property and scores for any new compounds, we need to load this model into StarDrop. On the Models tab, right-click and choose Open Model from the menu. Open the model file Serotonin Transporter log Ki.aim. You'll now see that a new model, Serotonin Transporter log Ki, is displayed in the Custom branch in the Models tab. StarDrop will now be able to use this model in the prioritization of compounds during the Nova idea generation process. Change to the Nova tab and select all 3 rows in the dataset by clicking in the top left corner. Click the arrow button to start the Nova wizard. The Nova setup wizard will be displayed. On the first page you can choose whether to run the idea generation or the library enumeration tool. For this example, choose Nova Ideas Generation and click Next. The Specify Input Structure page of the wizard will show the structures we have selected from the dataset. If you wish to indicate regions of the molecules that must remain unchanged, then you can draw around them with the mouse to create a mask. Selecting the individual molecules on the left will allow you to define individual masks for each molecule. However, in this example, all of the molecules contain a common substructure. Rather than having to draw this for each compound, click the Find Common Mask button. The naphthol group will now be masked on each of the compounds. Click the Next button to go to the Select Transformations page. Nova will search the database of available transformations to find those that apply to the input compounds. On this page we can select which transformations we want to apply. They are grouped to make it easy to pick certain types of transformation. The Manage button enables you to reorganize the transformations or import your own. Click the Show All option to see the full library of transformations, including those that do not apply to our specific structures. You can open the groups of transformations by clicking on the arrow next to the group to browse the individual transformations. The local transformations are those provided with the Nova module. If you also have a license for the Bioster module, you will see a database of over 23,000 precedented bioisosteric transformations manually curated from the literature. In this quick example, we're only going to select a small number of transformations. In this case, the 3 transformation groups related to rings: ring addition, ring modification, and ring removal. Untick the boxes next to the other groups and the Bioster library. With only these 3 items selected, click the Next button to go to the Control Output page. Here we can choose how many generations of transformations to apply. In this case, change the number of generations to 3. When we apply multiple generations of transformations, then all of the molecules created in one generation will be used as starting points for the next generation. This can result in a very large number of compounds being created. To restrict the number of compounds used as a basis for subsequent generations, tick the Select Compounds at each generation checkbox. First we choose a method. We can select compounds on the basis of a property, a score, chemical diversity, or a combination of these. If a property or score is involved, then we can indicate whether it is desirable for this to be high or low. In this case, we're going to make a selection that is biased entirely towards having a high score against the serotonin scoring profile. The bias slider will have a diversity of 0 and a value of 1 to show that the diversity will not be considered in this instance. We can then define the selection criteria. In this case, choose the best 15 compounds. Click the Next button to go to the Apply Filters page. Here we can indicate any structural features which we would like to ensure are not present in any of the new compounds. Compounds that contain any of these will be removed at the end of the process. A number of published sets of filters are available, and by clicking the Import button you can add your own, but in this example we will just use the undesirable fragments as our filter. On the final page we can give the Nova session a name, in this case Serotonin example, and add any other relevant notes. The session name will be used for the new dataset that's created. Once we've done this, start the Nova idea generation process by clicking Finish. This Nova process will take a couple of minutes to run, and while the process is running, an indicator will show which generation is currently underway, along with the best property or score value achieved so far. For this movie, we're going to skip ahead to the results. Once complete, a new dataset called Serotonin example will be displayed in card view. We can colour the cards to show the different generations of compounds by clicking on the Colour button in the card view toolbar, then on the Cards tab, choosing the property Generation from the drop-down menu. From the resulting display, we can see that of the initial 3 compounds, 1 in the top right resulted in the selection of compounds only from the first generation, and none of the subsequent generations had a sufficiently high score to be selected. Another compound, at the bottom, did not result in any children that were selected, while all of the second and third generation compounds were generated from only one of the initial compounds, in the centre. We can now choose to colour the cards by the overall score by clicking again on the Colour button on the Card View toolbar, choosing Cards in the Colour by dialog box, and choosing the property Serotonin Scoring Profile from the drop-down menu. We can now see that most of the high-scoring compounds, those which are the most yellow, are in the second generation. You should also note that the links between the cards are coloured by the change in score between the corresponding compounds. A large increase is shown by a red link, a large decrease by a blue link, and a small change is shown in grey. You can zoom into the display using the mouse wheel, or alternatively use the Control and equals keys. Looking at the highlighted compound, you'll note that the biggest improvements in score from this compound result from the aromatic to thiophene and 6-membered aromatic to furan transformations. You can see this transformation in more detail by clicking on the link on the cards. You can also choose to see more or different properties on the cards by clicking on the Design menu in the Card View menu bar at the top of the display. Now switch to the spreadsheet view of the dataset by clicking on the Table View icon on the toolbar to the right. The compounds in the dataset are sorted to show the compounds with the best property or score at the top. The dataset contains a column showing which transformation was applied to generate each compound from its immediate parent, and a column indicating in which generation this occurred. Select the first row to see this compound's parent molecules and any subsequent children in the viewer on the left. This compound was created in generation 2. Sometimes the same molecule can be generated from different parent molecules. In this case, all 3 parent compounds could be transformed with the aromatic to thiophene transformation to produce this molecule. Notably, all 3 parent compounds had scores of under 0.3, but the introduction of the thiophene ring significantly improves this. Finally, notice that the 4th best scoring compound produced is actually the drug duloxetine. For more worked examples looking at other StarDrop features, take a look in the tutorials section of the Optibrium community.